This is LJ, and today, we have breaking news. Kauda Team reported some groundbreaking work enabling collaboration, safety and reinforcement learning on Kauda Robotic Arm using Spatial AI and MyriadX powered EdgeAI devices OAKD. This is Kauda Studio. It is Unity application with virtual environments where Kauda digital twin lives. Virtual environments like this one are perfect to do training and simulation for robotics. Also for synthetic dataset generation with automatic labeling. You can check some of our related work with the virtual supermarket for synthetic datasets or virtual city with bus driving around. But what is Kauda? Kauda is open source, 3D printed, 5-axis and desktop size robotic arm. Kauda is very affordable and perfect for any robotic enthusiastic and research. Kauda Digital Twin is virtual version of Kauda Robotic Arm connected to a real Kauda using Bluetooth. If you want to know more about digital twins and especially Kauda and OAKD digital twins, please watch the following OpenCV webinar we had the pleasure to guest. Today, we are on Virtual House exploring applications for Kauda Robotic Arm at home. Desktop size of Kauda makes it perfect to place Kauda anywhere. Let's bring an extra arm to the kitchen. Let's 3D print one Kauda. Disclaimer, 3D printing usually takes a bit more time. Ha ha ha. To bring Kauda to the next level, let's upgrade Kauda with two MyriadX powered depth cameras called OAK. One camera allows Kauda to perform depth/spatial computer vision/AI and unlocks the power of reinforcement learning on EdgeAI. The second camera allows collaboration and safety. Collaboration and safety is basically monitoring and observing the working area of Kauda. Monitor feature detects when human enters on Kauda working area and pulls the robot. Of course, you can use any standing pole with OK cameras, but if you look for someone to watch Kauda robot while working, no one better than BD-1 robot from Star Wars. If you want fancy standing pole for your camera, check related info. However, okay, let's check the first time ever spatial computer vision/AI task Kauda is performing. Oh, is just playing with some fun. But good starting point. The second camera is performing Spatial Tiny Yolo V3 to detect objects in 3D position, so Kauda can touch objects dynamically. But wait! Kauda is using reinforcement learning model to touch the fruit once detected by Spatial Tiny Yolo V3. Awesome! Unlock reinforcement learning potential on EdgeAI. In order to BD1 to detect human close to Kauda, we are running Spatial MoveNet plus Blaze hands and hand gesture recognition pipeline on the first camera. MoveNet is brand new body pose estimation model released by Google on May 2021. There are two models called Lightning and Thunder. This one-stage model returns 2D body landmarks and it's running on RGB camera. Using spatial capabilities of OAKD, we align RGB and depth information and then retrieve 3D position of each body landmark. On top, if risk landmark is detected, we run Blaze Hands Detector. Blaze Hands Detector is hand landmark detector from MediaPipe. It's two-stage detector. First runs palm detector and then using regions to extract hand landmarks. Finally, with the landmarks, we run simple gesture detector based on finger open/close state. Spatial information is related to the camera. So thanks to the virtual environment, we can merge Kauda and camera's info on one common space. BD1 can detect when human is entering on the working area of quarter. Working space is defined by a cube area in the space. BD1 is pausing quarter activity when human enters, preventing any damage/collision, safety work, and enabling collaboration. BD1 resume quarter activity when human leaves the working area automatically or waiting for hand gesture from human depending on which policy is defined. Well done, BD1. Now let's take a look on the second pipeline. Using Spatial Tiny Yolo v3 to detect objects and 3D position enables Kauda more sophisticated tasks. But how is possible to unlock reinforcement learning on EdgeAI? Kauda Team transformed the virtual environment with Kauda and OAKD digital twins on reinforcement learning environment thanks to Unity ML agents. ML Agents is Unity framework that allows to use Unity as RL environment to train RL agents using state-of-the-art policies. In this case, Kauda become the agent. The goal for Kauda is to learn a model for touch dynamically an object in an efficient way. The policy selected is PPO. The model inputs are called observations and model outputs are called actions. In this case, observations are 3D position of control point of Kauda, cube. 3D position of object returned by Spatial YOLO, distance between them and bounding box. Reward system is based on small penalty and big reward when Kauda control point is close to object, distance close to 0. Result of training process is ONX file you can use on host to inference. We want to unlock reinforcement learning on EdgeAI, so let's transform the ONX model to OpenCV IR and then to MyriadX blob. Ops transform is not straightforward. Let's take a look how we can modify the ONX model to run it on OAKD. Basically, we need to transform unsupport OpenCV random normal like node to additional input of the model and provide the input from the host. After some hacky JSON file transform and manual edit, we have compatible OpenCV model. Now the transform to OpenCV IR and MyriadX blob file worked fine. Amazing! Finally, we created C++ pipeline with the two stages. Spatial Tiny Yolo v3 and PPO reinforcement learning using Spatial YOLO as input and providing extra input to fill the random normal like data. Then integrate with our Unity plugin and we created our own depth AI agents, so we can compare host ONX agent and EdgeAI agent inference modes side by side. Easy job! Maybe the task learned is not very complex or exciting, but shows that we could take any reinforcement learning task to EdgeAI. If you want to see how we trained 3D ball balancing task and port to EdgeAI, take a look on the second part of the video. Are you still watching this video? Now we have an exciting second part showing other applications of OAKD digital twins inside Unity, like face detection for airplane control, head pose for Nautilus demo and head rig, face emotion to open doors, creating pipelines for OAKD inside Unity without coding, running pipelines on OAKD using Unity virtual cameras, so we can run Tiny Yolo v3 on virtual city and generate synthetic datasets with automatic labeling in minutes for training your own models with few clicks workflow and validate inside Unity to close the loop. Too much information. Let's start.